Hi, my name is Jason Roelofs. I work at Collective Idea, and I'm here to talk to you today about Pantry, a tool that we've been building the past couple of months to help us manage our server infrastructure, how we host and manage multiple applications across multiple clients, and how we deal with our chef stack accordingly. I'm going to go over what it is, basically where it came from, how it's used, and go from there. So, what is Pantry? At its core, it's a plugin-based client-server asynchronous remote execution framework, which is kind of a boring way of introducing it. So I'm going to try that again, and so what is Pantry? Pantry is Devops automation pipeline framework. It lets you use tools of your choice. If we're a chef company, or if you want to use Docker with Chef or Packer or whatnot, and it uses the principles of convention over configuration to offer up a DevOps kind of glue between how the tools that you choose you want to run, your servers you're trying to configure. It's a glue between those two, which kind of gives you a framework on how to communicate with them, how to send commands, how to run your stack. I want to be clear, this has kind of been a confusing point for people who I've talked with Pantry before. Pantry is not itself a configuration tool. We didn't build something to compete against Chef or Puppet or any of them. Pantry is meant to be something that uses these tools and works with these tools. So it's not directly the competition for a lot of the tools that we use every day. Pantry, today is the first initial release of Pantry, an 0.1 release. What's out is Pantry Core, which is the execution framework that everything is built off of, and Pantry Chef, the first plugin, which is basically a minimal chef server, chef client replacement that offers up just the functionality and the features that we really need. So where did this come from? At Collective Idea, we're, as you heard earlier from Chris, we're a consulting shop. We have a number of customers. We run their websites, and we maintain a number of applications, including our own. All these apps have their own kind of chef stack to them. They have their own cookbooks. They have their own application info, which is environments, data bags, roles, and whatnot. And over time, we've been basically copying these cookbooks from one to the other, making small changes, trying to copy changes back across. And as you expect over time, the cookbooks themselves have kind of grown out of sync with each other. So they're all kind of different. And we've got to the point now where we need to get a solution because it's kind of getting untenable. Applying security updates and whatnot is really kind of a pain right now. So we're trying to find a solution to better share our cookbooks across our applications. So we looked into a couple of solutions, obviously the first one being Chef Server, and then we investigated Burke Shelf and Librarian among a couple others. So obviously the first one we looked at is Chef Server, and found out pretty quickly that it doesn't actually solve our problem either. There's a fundamental design decision in Chef Server that organizations, which are their delimiting factor of how you keep information separate from each other, they don't share cookbooks. There's no way in Chef Server to share cookbooks directly between organizations. So we decided and we did actually look into a way of having an organization that was just the cookbooks and then sharing those across the applications, and that was very quickly painful and untenable, and we decided to drop that. We took a look at Burke Shelf, and this was as Burke Shelf was kind of turning into version 3.0 and the movement of ownership from Riot Games to Opscodes. Things may have changed since then, but when we were playing with Burke Shelf, it was kind of a confusing tool for us. We weren't quite sure what exactly it was trying to accomplish. If it was just going to try to be like a bundler for cookbooks, or if it was something that's sitting between you and your Chef Server. And it kind of felt like it was overly complicated, and then it split up into Burke Shelf and Burke Shelf API to facilitate finding cookbooks across the Chef Server or get whatnot. So kind of confused by that, weren't sure exactly how to use it best, and we didn't really find it very reliable at the time. What we did get working would maybe then start throwing errors a couple days down the road if a small version bump or who knows what. We weren't ever to actually really figure it out. So that one kind of fell off the list too. We also took a look at Librarian, which has been around for a decent amount of time in the chef world. Didn't look a whole lot into it. I would imagine it does a pretty good job of what it claims to do, managing your cookbooks across a couple of your applications or whatnot. But it was about this time that we started looking into Packer and other DevOps tools and realized that maybe looking into just a chef-only tool wasn't the right solution for what we really needed in both now and in the upcoming future. So we did discuss and think about what if we did away with Chef and went to a different tool. We went to Salt or Puppet or any of the other numerous tools that are out there. Of course, that would be throwing away many thousands of hours of work and years of knowledge that we've accumulated, that I personally have accumulated over time at Collective Idea and my previous jobs. I've basically been doing Chef for a number of years. And we couldn't really tell going through the other tools that are available whether they would have helped us solve the problem or if they have just solved one aspect of the problem and pushed off another problem to be solved later down the road. So we decided what we were going to build. If we're going to build something, it would have to work with Chef, work with what we've got, and move on from there. So we started I took a step back and started thinking about what is top-level view, what's DevOps, how is the field looking today, what's there, how can we solve this problem, and DevOps is it's a fun environment to be in. There's a lot of great people. There's a lot of great tools. The tools are constantly getting better and proven, and a lot of people are using them. You know you can choose a tool, and you know it's going to solve a specific problem. The communities are really open and helpful. There's a lot of knowledge flowing in between them. There's a lot of ideas coming out from all the sides. But when you come down to trying to use a lot of these tools and use a lot of these ideas, there's still a decent bit of custom development that everyone still needs to do when they set up their new server stack. Taking a tool, putting on the servers, what goes in between there? How do you get everything set up so that you actually can use what you're wanting to use? And on top of all that, coming up with the name of this talk, I initially was thinking DevOps silos, but that really wasn't the right term. I feel that DevOps is more of, we're kind of a bunch of islands in this ocean of operations. The Chef community and the Puppet community and Salt and Ansible and their CF engine, and now we got Vagrant and Packer. And we know about each other and we talk with each other a little bit, but most of the ideas kind of stay within these islands and within these communities. And everybody is, in the end, solving a lot of the same problems, just with different tools. When you're setting up a new server or a new stack or a new application or whatnot, everybody has to answer the same questions. And so it kind of condensed down to the main questions that people have to answer when they're setting up new servers, like where do I store my data? Where do my cookbooks go? Where do my manifests go? And salt pillars and all that stuff. How do I provision the new servers? How do I configure these servers? Or how do I run these tools? How do I share my configurations across the various apps that I have to run? And last but definitely not least, how do I make sure that this data flowing across my network, flowing across the internet, how do I keep this secure so that someone doesn't actually intercept important API keys and passwords and whatnot? So that's where Pantry comes in. This Pantry is the glue, as I said before, to set up a stack so that you can use the tool of your choice to set up and manage your servers. And Pantry offers a number of specific answers for a lot of these questions. For storage, it's obviously recommended that you put your configs in a source control management of some sort. But other than that, for operational purposes, the information that you're trying to use on your servers goes up into the Pantry server, stored on the file system there and available to all clients that are part of this network. And then that's all contained in one little area that doesn't pollute the file system, so it's easy to add and remove as necessary. How you provision and configure your servers is the realm of either, maybe it's not Pantry's job, maybe it's something else if you're setting up bare bone hardware or whatnot. But configuration can be done through Pantry plugins, which is what adds functionality support to Pantry. Sharing configuration is something that is by design in Pantry. everything that gets uploaded to a Pantry server is technically accessible to all the clients that connect into this server. So it's easy to set up a packer which can talk to the cookbooks and use all that together in one piece. We don't have any limitations on who can access what data. That isn't to say that Pantry isn't secure. Security is actually a very important aspect of Pantry. So does it keep it secure? Well, yes, but that's a much bigger part of this talk, and that'll come later. Using Pantry is simply gems. Install the gems. It gives you a couple of binaries. You have you have your server, and the client's connected to the server, and then there's a command line interface, which you use to actually send commands into your Pantry network and interact with what you've got set up. Pantry is a very minimal set of dependencies. It's a Ruby 2.0 plus project. Uses ZeroMQ for the network communication between the server and the clients, and it will work on 3.x, but is recommended if you want to use the security layer, which I'll talk about in a sec, that you'll need ZeroMQ4 and the libsodium library installed. There are plans to set up some sort of omnibus installer so that this is easier to just drop onto a server without needing Ruby installed or any of that stuff, and just kind of works on itself. A couple of the rundown on the parts of Pantry. The server is the brains of the whole thing. There's, in most cases, one server for all of the clients and all the applications. It holds everything. All the communication goes through the server, so every command line interface invocation will send a request through the server, and the server will figure out what clients need to actually run this command. The client itself is simple. It just runs the commands it's told. It can be configured with a specific identity to identify it across the whole network. It can be configured for working for a specific application, an environment application, and across specific roles. And these are the values that are used to figure out which clients need to run certain commands. So you can specify through the command line tool, run on all clients, run on some clients, run on a specific client. As an example, to see the check-in status of all the clients for my production application, you say my application in the production and run the status command. And then when the Chef plugin's installed, you can run Chef, say, on your staging servers with just a simple Chef run command, and that'll run. And then Pantry itself is easily accessible through a plugin system, which uses Ruby gems underneath. The initial hooks are commands that can run on the server, or commands that can run on the client. And I've signed up for a lightning talk to show what the details of how this works. So if you want to know more, I'll be there to show that. So if we come back to our problem of lots of apps, lots of cookbooks, information just kind of spread out, the idea behind Pantry Chef and then what came out of this Pantry is we want the server to hold our cookbooks, to then keep separate application information, the environments, the data bags, and the roles, such that clients can come in and say, hey, I'm this application, give me the cookbooks I need, give me the information I need, and it'll configure itself to run, and off it goes. This is a very minimal Chef server replacement. We don't do any sort of users or permissions management, no extra accounts, there's no web front end. We don't do cookbook versioning because we've personally never needed it. And it's if enough people feel it's necessary, and it's easy enough to add. We don't do a whole lot with cookbook dependencies. We let Chef figure it out. We run on the clients. We run Chef solo, so we just drop all the cookbooks onto the client, and we let Chef figure it out from the run list what cookbooks actually need to run. And then the configuration itself on what clients run what is done through regular Chef files. So I upload your roles. The roles contain the run list, and the run list tells Chef what to do. So there's no actual work to be done on Pantry side. You just configure, install the plugin, upload your data, and run Chef, and it figures it all out for you. And this is the whole set but one. It's a list of commands for how to use Pantry Chef. You upload your cookbooks, your environment, your roles, your data bags, the application, and then run Chef, and everything else just happens automatically for you. So from here, it's time to talk about the answer the question that I put off earlier, security. Pantry takes a slightly different aspect of security than a lot of the tools. We know very well, it's like we know we didn't want to build our own because that's a very difficult thing to get right. I don't profess to be any sort of crypto guy. I look at what people do and I read about it, but I wouldn't be able to implement a really good one on my own. Getting it wrong is a really bad thing. And I feel that sometimes it can be hard in today's day and age to really know what is and what isn't secure, and it seems like that is changing quite a bit in the last couple of years. So in Pantry, the default security is that, well, there is none. The initial setup is plain text communication, and we don't really do any authentication on what clients can connect in. This isn't to say there isn't a layer of security on here, but we felt it best to make the default just empty for a reason which you understand in a sec. It is obviously recommended if you choose to go this route to set up security on the sockets using like SOCAT or SSH tunnels or S tunnels to make sure that that stuff is actually encrypted. Why didn't we use OpenSSL? It is the de facto standard. There's tons of protocols, tons of ciphers, and it's becoming ever more complicated on which protocols and which ciphers work well together, which ones don't work well together, which ones are secure, which ones aren't. And we didn't want to have to keep track of the ones that we did use, where there are problems with it and need to switch to others. And also, there was no actual built-in support for OpenSSL use in ZeroMQ, and actually adding that is not a trivial thing due to the complexity of the OpenSSL C API. We didn't really want to deal with that. So what we did go with is something that's new in ZeroMQ 4. It's called CurveZeroMQ. It's an implementation of a new protocol under development called CurveCP. It can be easily turned on in Pantry with just a simple config setting. And what CurveCP is a replacement for TCP that builds a fully encrypted pipeline using UDP underneath and using this Curve 25519 encryption algorithm. It's a pretty complicated thing. Right now, CurveCP in itself, I don't believe is run anywhere. It's more of a prototype testbed, but its ideas are starting to spread in a number of places. A quick jump down one more level to what is Curve 25519. It's an implementation of elliptic curve cryptography, and the name comes from the base prime number that it uses. ECC has, I feel, gotten a bad rap lately with the NSA revelations. The number of NIST curves that were previously well used and considered secure are now considered backdoored. But that isn't to say that ECC isn't itself secure. ECC is actually very, very solid mathematically. You just got to make sure that you choose the right curves and the right numbers. If you're unfamiliar with ECC, there's an article on Ars Technica, which is probably the best description of ECC I've ever seen. It helped me really kind of understand what it actually is. And then the bottom link is a link to the information page for this ECC curve. So CurveZeroMQ then is an improved implementation of CurveCP using ZeroMQ as the networking layer instead of replacing TCP. For those interested in the security, upcoming and the new security changes, NaCl and libsodium are two important libraries to keep in mind. NaCl is being developed by Daniel Bernstein and a number of others, and it's more of kind of like CurveCP, a testbed and a prototyping tool for these new cryptography ideas. And libsodium came around because NaCl is difficult to use, wasn't really portable. So libsodium is a fork of NaCl that makes it packageable, portable. It's very easy to install on a lot of machines now, and it only includes the well-known, strong, and working on being proven cryptography primitives like Curve. CurveZeroMQ, by design, prevents a lot of many common attacks that we've seen on the internet. But it is still very young. It is only actually released as of, I think, 2 months ago. And while a lot of people are using it, it is still not considered vetted by the cryptographic community. So is best for us to add this as an opt-in instead of an opt-out until more people are comfortable with its strengths. And then its website is there. So the attacks and how it stops it, the curve 25519 is a typical Diffie-Hellman key exchange format, so man in the middle doesn't work unless they have both keys on both sides. Packet replay is prevented because every packet uses what's called a nonce, which is a number only used once. So if you try to replay a packet, the system will notice that nonce has been replayed and will just drop the packet because it can't actually decrypt it. Altering and forging packets is similarly difficult. Any alteration to an existing packet immediately makes it unencryptable and it gets dropped, and forging again requires the actual keys to create a valid packet. It also has preventatives for amplification attacks, much like the DNS and NTP DDoS attacks we've been seeing as of late, where a small request out creates a whole lot of traffic out to a forged client. But instead, what Curve ZeroMQ does is simply make that initial request that causes a response to be bigger than the response. A really neat attack that Curve ZeroMQ stops is key theft. So if an attacker is sitting there between two endpoints, listening on this encrypted communication stream and recording it straight out to disk, and then this attacker ends up getting the keys, public-private keys for both endpoints, he still can't actually decrypt that communication stream, because instead of using those keys directly to encrypt, those keys are used to create transient keys, and those keys are then used to encrypt and decrypt the communication, which are then dropped as soon as the pipeline is closed. So once a pipeline is closed, the keys are gone, there's no way of getting access to them again, and you're basically stuck having to brute force a save stream. It also prevents client identification because nothing is ever sent via plain text. Even the initial handshake is sent via these transient keys using the Diffie-Hellman key exchange. And then Curve ZeroMQ makes extra specific that any connection that comes in doesn't actually create any memory in the allocated memory in the system until it is a valid connection to a valid client. So you don't have to worry about someone hitting with a bunch of junk and your server going crazy with memory usage. So Curve ZeroMQ and Pantry we use Curve ZeroMQ to do encrypted communication between the server and the clients, as well as authentication on who can actually connect into this server. And so for this to work, the clients and the CLI, which is actively a client, needs their own public and private keys and the server's public key. And the server will know what clients are allowed to connect to it via the client. It'll have a list of client public keys because it then is the one that actually generates these key pairs. So to go back to the initial question, how to keep it secure, Pantry is secure as long as you opt into the Curve security or if you set up your own S-tunnel. Obviously, the Curve stuff is technically use at your own risk, but there is a lot of really smart people behind it, and there's an ever-increasing number of tools and utilities who are using this encryption and this communication protocol that I think will find that it's considered incredibly strong and very secure. And there's always improvements coming. So to recap, Pantry is a DevOps pipeline framework. It offers a way to connect between your dev environment, your tool of choice, and the servers you're trying to configure, so you don't have to keep setting up your own custom stack every time you're setting up new servers. I'm trying to basically just remove the tedium of setting up more DevOps. Pantry and Pantry Chef are out now, and there's more on the way. We're investigating Packer. We're probably going to start looking into Docker, and all these can be part of the Pantry ecosystem. So I want to give a call out to the two main libraries that Pantry uses. ZeroMQ is awesome. I've never been happier building a tool that actually does socket communication, because socket programming just kind of sucks. And it offers a whole bunch of built-in communication topologies that just work right out of the gate, like a pub sub and just basic request reply and all sorts of asynchronous stuff. Also, Pantry makes heavy use of celluloid, which is also awesome because concurrency sucks, and celluloid does all this for us, using actors, futures, conditionals, a lot of really great ideas. It all comes together in a really easy-to-use package. And also, it comes with celluloid ZeroMQ, so that was already there for me to use. So if celluloid with ZeroMQ, it's like the thing basically just wrote itself. It was great. So that's Pantry. The website is pantryops.org. There is an organization up on GitHub at /pantry. Yeah, so that's our tool. We hope you check it out and let us know what you think. Okay, thank you.